So this is going to be like a little review with exponents first, then we'll try to play the game if we have time. If we have time, but we have to try to learn the rules, remember the rules first, so then we can try to play the little game, okay? So this right here, which is equivalent to this one, if we simplify it, we have to recognize that there's a power on the outside of the parentheses. So this is the power to a power rule. Power to a power rule means that any power on the outside of the parentheses has to get multiplied times any power on the inside of the parentheses. So what are you going to do with the 3 and the 5? You're going to multiply those exponents. And what's 3 times 5? You should get r to the power of 15. That's the power to a power rule. Notice the difference between this one. Do you see a power on the outside of the parentheses anywhere? Do you see a power on the outside of the parentheses? No. So this is no longer multiplying exponents. This right here is a multiplication problem. And the rule for multiplying, does that mean you're just supposed to go through and start multiplying all the numbers? No. We can multiply our coefficients. What is that going to be? 3 times negative 5. That gives me a negative 15. I'll do it on the little sticky. So that gives me a negative 15. So now for my m, I have m to the power of 3. What am I going to do with this m, which is the same base? Multiply the big numbers. Don't keep multiplying all the little numbers. We're going to add the exponents. That's the rule. Add the exponents if they have the same base. So for my m's, I'm going to add 3 plus negative 6. 3 plus negative 6 is, thank you, negative 3. Now I'm looking at my n to the power of 4, n to the power of 7. Once again, I'm going to do what with the 4 and the 7? Add. What's 4 plus 7? 11. Now, if you notice, none of the answer choices look like that because there's like a small rule embedded here. No, you cannot leave your answer with the leftover power of a negative, if that made sense. You cannot have an answer with a negative power. So we are going to actually have to change this a little bit. We're going to change this and we're going to move it to the bottom of the equation. I'm sorry, of the expression. So now the negative 15 stays up here and the n stays up here. But now I have to kind of turn it into a fraction. And the m is going to now be to the positive 3, but now at the bottom of the expression because you cannot leave a negative exponent there. So which one? Oh yeah, that one they got right. So it was a negative 15, n to the 11 is on top, m to the 3 at the bottom. All right. We're just trying to remember these rules. So the other rule was no negative exponents. You could not leave a negative exponent left in your simplified answer. All right, look at the next one. This one's different. This does not look like a multiplication problem. This looks like a division problem. And divide really means you are supposed to subtract the exponents that have the same basis. So if you look here, we have some a's. A to the power of 4 and a to the 3. What am I going to do with the 4 and the 3? Come on now, look at this. Subtract the exponents. So that's going to leave me with a to the power of 4 minus 3 is 1, invisible 1. Now for the b, what's 5 subtract 2? 3. And for the c's, what's 8 subtract 6? 2. And this should be my answer. And whenever I do the subtraction, it automatically goes to like the top of the problem. So this answer should have been a, b to the 3rd, c to the 2. Yeah, I never noticed that. All right, so number 4. This has a division problem right here. However, it also has a power on the outside of the parentheses. So the power on the outside is the same rule. If there's a power on the outside, it has to get multiplied times any power on the inside. It doesn't matter if it's on top or bottom of the fraction. So what is that going to become? What am I going to do with this 3 and this 6? And what is that going to give me? Power of what? 6 times 3 is 18. And then what am I going to do with this 3 and this 3? Multiply again. It's like you're kind of distributing here and distributing here. It's a power of 9. So now, same thing here. Just divide really means to do what to the exponents? Subtract. So 18 minus 9. 18 minus 9 is 9. So the final answer should have been x to the 9. Okay. Please.
How do you think that person chose x to 7? Is it wrong? No, they did it wrong, but why?
I think they might have just guessed on that one.
Right.
They guessed on everything.
Yeah, they probably guessed.
2, 3, and
They ain't got no words.
Wait, which one was that? Because some of us had A.
The answer is here. This person guessed on that, so we won't do that. All right, continuing to the back. Simplified form right here. Notice how they've like spread everything out for you. Once again, it is a division problem. And anything on top is going to cancel out to kind of make an invisible 1.
I know how to do it. Alright, so you gotta scratch the 2 x's right there.
This x on top and this x on top?
No, the bottom.
The one on bottom, yes. These two kind of make an invisible 1. Anything else can we cancel out?
The y.
One of these y's with that y down there. We cannot continue canceling x's because there's no more x's down here, and we can't still cancel y's because there's no y's left. So where is the 4 left? The 4 is left at the bottom. And these two y's, that's going to become y to the power of 2. Because there's 2 of them. Then there's just one measly old x on top. And that's your final answer, which should have been here.
I wonder how they got C. They added
That's how you do that thing.
All right. You probably need to then. If you haven't taken the quiz, you will do it tomorrow.
I know I can.
This quiz?
This one here. Yes. This one here. It says, which of the following is equivalent to this one? We just talked about that word equivalent.
It's the same thing.
That means it has to be exactly equal. Could you use your calculator for this one?
Yo.
Yes, you can.
But I'd rather not.
You definitely can, but let's just talk about it just for star purposes. In the y1, you can put exactly this, parentheses x to the third, parentheses power of 2, times. You can put exactly this in the y1. This person thought the answer was D, so put that in the y2 and see if everything is exactly the same in the y1 and the y2.
Now it looks like it's
All right. But let's see, what would I do with this power on the outside in that one? I would multiply. So that would give me x to the 6. Then with this power and this power, I would multiply 24. But now would I multiply again? No, because there's no powers on the outside of the parentheses. I would do what to these? I would, what do I do with these? Remember, multiply means to add the powers. So 6 plus 24 is 30. They were right on that one. Bless you, bless you. This is a rule right here. Everybody keeps forgetting. I played a video that said it 5 times in the other class, and when we did the problem, someone said, oh, it's 0. It's 0.
It's not.
It is not 0.
It's uno.
Anything,
0 is really 1, right?
anything, no, to the 0 power equals 1.
That's what I was saying. Anything to the 0 power is 1.
Anything to the 0 power equals 1. It could be 88 to the 0 power, it equals 1. It could be 888 to the 0 power, it equals 1. All right, so make sure you remember that rule. And the last one, I can tell you why they got it wrong on this one is because they didn't show any work. That's one way to guarantee you keep getting problems wrong. It's just don't show work. No, please show work on all of them, okay? This is a division problem, so be very careful. Dividing means I'm going to actually take my 24 and 6 and actually divide it. So 24 divided by 6 is 4. What am I going to do with the p here and the p here? 6,
Oh, you can erase it.
take away 2. I'm subtracting, so that's p to the 4 because for my p's I had to do 6 minus 2. Is there any other, wait a minute, I'm going to make a line because there's no other q's. Look, There's no other Q, so I need to keep that Q to the 2 at the bottom. But for the R's, you have to be very, very, very careful.
You gotta make it a positive.
Because this -6, you're going to actually subtract a -2. All right? This is where everybody gets it wrong because they think, oh, that becomes R to the -8. We are not combining it if some's on top and some's on the bottom. We are going to actually take -6 and subtract it from a -2. So that really means we have to do -6 plus 2. So that's going to give me R to the -4. However, remember the other rule. What's wrong with this?
They're not going to the bottom.
We cannot leave a power
Make it a
negative.
positive.
So this comes down here with this one. And it becomes R to the +4. And then this is our final answer.